Next, we have Shuichi Ihara from DDN. Let's see. He's a senior manager, performance engineer. Performance engineering laboratory at DDN. Joined in 2010. He has several roles at DDN. Primary responsibility being I/O benchmarking, performance optimization. He's the manager of the Lustre development team to develop new Lustre features to solve customer concerns. Ladies and gentlemen, presenting Shuichi Ihara. Thank you, sir.
Today I talk about the OpenStack Cinder driver for Lustre. I'm Shuichi Ihara, Data Direct Networks. As you already know, the OpenStack, this is a very familiar the software environment. The OpenStack itself, one of the largest open source project that started in the 2010 by the LUG space and NASA. It's a huge community behind, then the community itself is so growing, then it's really active. The many people and the vendor and the involved in the open source, OpenStack, the project today. So the OpenStack itself, it's a widely known the software stack environment to building up the cloud infrastructure at enterprise system as well as a non-enterprise system. So this is the one of the tool set you can managing the whole cloud environment, including the public cloud or the private cloud wherever you want. Again, so the OpenStack is not only the one software stack, so this is an entire software stack, including the compute node, storage, the virtualized network configuration, so on. Then it's also the support, the API, the compatibility, Amazon AWS. So this is the simple diagram each component does the OpenStack. So as I mentioned earlier, the OpenStack that consists of the three or four major components. So one of the components is Nova, which is the providing the VM infrastructure, the computer node. The Neutron, this is also the important component in the OpenStack, which provide the virtualized the network infrastructure in the OpenStack. The storage side, so this is the main topic today. So the storage itself, they have several of the projects behind. So one in the Swift, the another one in the Cinder. Each of the components that talk to each other using the API, then they have a nice GUI, the CLI, the environment on the dashboard. So you can manage the single pane, manage the dashboard or entire stack. So they have also the security feature. They have the keystone, the identification. So you can manage the authenticated the environment on the entire OpenStack. The storage standpoint, so as I mentioned earlier, there's a major two storage service. So one is the object storage service, which called the Swift. The Swift, they support the full distributed API, the object storage platform. So you can put and get on the data through the HTTP REST API. The Swift itself, the support multi-tenancy, so you can create the isolated the environment, the storage environment using the authentication. For Cinder side, the storage service, the block service, this is called the Cinder. The Cinder provides the traditional block level the storage service to the VM. So for instance, the Cinder itself provides the OpenStack, the Nova, the service for the VM, the infrastructure, VM, the image. The Cinder, it's Cinder responsibility, the creating the image, then attaching, deattaching the image to each host. Then through the Cinder driver. Then the Cinder driver, so there's so many the Cinder drivers available today. So you can check this URL, the Cinder matrix, Cinder support matrix. So there are more than the 70 the Cinder driver is available for each the storage platform or on the file system, so on. However, so there's no Cinder driver for Lustre today. So that's why we have started the working for developing the Cinder driver for Lustre. So this is the Cinder, the architecture in general, not only Lustre. So this is the simple picture, the Cinder client, which means the CLI or the GUI, so request, the volume management, the request from the client using the REST API. Then Cinder API that receives that request, then validate it. So once the request is validated, on the Cinder API, put all the requests on the message queue. Then after that, the Cinder volume manager talk to the Cinder scheduler. Then Cinder scheduler does the scheduling based on the state, the latest of the state. So such as the volume size and the utilization, the availability. So those are all the information based on the behind. Then after that, the Cinder scheduler generating the candidate, the job. Then finally, the Cinder schedulers dispatch each job to the Cinder volume. Then Cinder volume, finally, creating the attaching the volume through the Cinder driver. The Cinder driver just talk to the Lustre. So that's the Cinder driver. So we are working on developing. So what does the Lustre Cinder driver does? The Cinder driver, it's the same idea as the third-party Cinder driver. So just providing the block storage device to the OpenStack, the computer node. Then the Cinder driver itself just expose the Lustre, the namespace to the OpenStack. Then the OpenStack, the VM, the Nova, creating the VM on the OpenStack with a host. Then VM itself, the VM image itself, that is one of just a file on the Lustre file system. So this is a simple, but this is a huge amount of the opportunity. So we can make. So this is one of the bridge, the HPC and the OpenStack with Lustre. So you can set up the OpenStack, so one of the client of the HPC environment. Then you can set up one of the HPC enterprise system on the HPC platform. So the other interesting feature, the opportunity, the Cinder driver for Lustre. So we have many the Lustre specific feature there. So we can use those Lustre feature as one of the Lustre ecosystem for the OpenStack. So this is the quick diagram how the Cinder driver works. So the raster standpoint, just simple. So you can just set up the raster. So we don't need any the raster side of the patch. So you can set up the raster 2.5 or 2.7, 2.9, whatever you want. Then you can just set up the one of the OpenStack environment of the one of the client. Not only the one, but the multiple client is also supported. You can just install the OpenStack on the raster client using the Lustre Cinder driver. Then Lustre Cinder driver just expose the raster namespace to the OpenStack. Then after that, the Cinder driver creating the volume attaching to the Nova, which is the VM. But the Nova itself, it's the KVM, so it's running in the underlying on the base technology. So the raster standpoint, just we are providing the sparse file for the VM image for the KVM. So you can see just one file is creating for each of the VM as a raster boot image. So we have already the prototype. Then we have the pushing the Cinder driver patch to the OpenStack community. So right now, so the future itself is very limited because first priority merging the patch into the upstream the OpenStack first. So the configuration itself is very simple. So you can just specify the host name, the MGS, and the mount point on the raster file system on the client. Then just specify on the backend the file system name of the raster. Then, so once you set up the Cinder driver, the cinder.conf, then enable restart the Cinder. So the OpenStack automatically mount the raster file system. Then you can see, so the Cinder itself is mounted. The raster itself is mounted by the Cinder driver for the OpenStack. So you can also see, so all the OpenStack is command line is available. So once the Cinder driver is enabled, so you can check the what's volume manager is available, what's volume manager is enabled. So you can check the OpenStack volume service list. So the Cinder driver is available in here. So once you can make sure, the Cinder driver, the Lustre Cinder driver is enabled, so you can start creating the volume. So this is the same idea of the Cinder driver. So you can just creating the volume, the OpenStack volume command. So in this case, so we're just creating the 1 terabyte the image for the computer node. Again, so once you enable the Cinder driver, so all the OpenStack command is available. So you can check the volume with the OpenStack the volume list. Then also so once you create the volume, so you can check the raster file system what file is created. So once the volume is created, so the raster standpoint, just a 1 terabyte the sparse file is created for the VM. So it's not data is there, it's just a sparse file. So after the volume is created, so you can just create the VM on the Nova, then attaching that's create the volume. So once create the VM, the OpenStack, the VM is started automatically. Then after the boot up to the VM, so you can just SSH the VM, then access to the VM. So you can check on the VM, the root file system, the 1 terabyte, because so we create the 1 terabyte the root image. So that is you can make sure the Cinder driver, the Lustre Cinder driver is working for the VM as a root image. So we started some of the benchmarking and the testing in our laboratory. However, so we didn't have much time for the testing and the benchmarking. So I wanted to show the one simple benchmark result here, but so still the testing is running. But I wanted to show the one simple stuff. So benchmark configuration, it's not a specific, just a simple. You can set up the standard MDS and the OSS wherever you want. So in this case, so we use the SSD on the both MDT and the OST, but no many the SSD. So the 4 SSD for MDS, 9 SSD for 1 OST. So we only use just one OST then to make sure how our IOPS is going from the VM. Then I also set up the Lustre client, then install the one of the OpenStack distribution dev stack. Then after they install the dev stack, then create the 8 VM on the OpenStack. Then allocate the 4 CPU core, the 4 gigabyte memory each of the VM. Then also creating the 250 gigabyte the volume for each of the VM. That is through the Cinder driver or Lustre. So the benchmarking itself, it's a simple random read, 4K random read testing. Again, so the VM itself, so using VM image itself, this is a file on the Lustre. So if you run, you don't need to mount the Lustre file system from the VM. You can mount the Lustre file system from the VM, but you don't need. So once you run some of the benchmarking to the root file system, that means so you are doing the I/O to the Lustre, because through the image. So in this case, so we don't mount the Lustre file system from the VM, but so just run the FIO to the root file system, the inside of the VM. Then so we have the 8 VM, then run the FIO on the 8 VM the simulatory. This is a random read testing. So we disable all the OSS caching. Then the VM the cache mode is known, which means so direct I/O from the VM to the Lustre. Then also I use to the direct I/O to FIO. So completely no caching to any layer. Then I create the very large file for the read. Then after the reads, after the write the files, then remove all the caching, then run the read testing. So the 1 VM, so we are achieving the 18,700 IOPS from the VM. But so we don't know why. So I don't know why. So it's not scaling on the 4 VM case. Maybe so that the CPU the allocation it's not properly. So we need to investigate more. But after the 8 VM run the FIO on the simulatory, so we are getting 115,000 IOPS from the 8 VM. Again, so this is still a single client, but the 8 VM is running on the one single client. So, but we are getting the 150K the IOPS. So this is not so bad. So we are still investigating so how to compare to the bare metal server, how achieving the maximum the IOPS from the VM through the Cinder driver. I also introduced some of the development status. So again, so there's nothing to work for the Lustre. But so we need to do creating the patch to the Cinder, the OpenStack, the dev stack. Then we are going to we push the patch, all the patch to the Git, the upstream, the OpenStack already. Then those patches under the review by the community, the contributor. But you can access the those patches today. So it's still under the review, but you can cherry pick up all the patch in the dev stack. Then you can test the OpenStack, our Cinder driver for testing. So the other important stuff. So the OpenStack, the community, it's also the required the code inspection and the regression test before the merging the patch. It's the same idea on the Lustre. However, so we also set up the CI infrastructure in our somewhere, because the third-party vendor providing the Cinder driver, but OpenStack community doesn't have all the the backend infrastructure. So each of the vendor have to set up the CI infrastructure. It's a sub CI infrastructure against the master CI infrastructure on the OpenStack. Then, so once the patch is submitted, then that is the Cinder, the Lustre Cinder driver, the master, the Jenkins, the Git, the trigger, the Jenkins or the Git, then running the regression testing our infrastructure, the CI infrastructure. So so in order to support that kind of the infrastructure, so we contribute the resource to the OpenStack community. Then we set up the CI infrastructure OpenStack environment for the Lustre Cinder driver. So it's available today. So you can see the DDN, the CI infrastructure, the name on the Git on the OpenStack. So you can now the pushing. So it's not for us, but you can push the Lustre Cinder driver, the patch to the OpenStack community today. So once you push the patch to the OpenStack, so for the Lustre Cinder driver, automatically trigger the Jenkins system on the Git, then started the regression testing our infrastructure. This is it's running well. The future plan. So the first priority, of course, we need to merge the first patch into the upstream, the OpenStack first. So this is really the important stuff. So that's why. So right now, the future itself, the minimize as much as possible. Then so once we merge the patch, the upstream, the OpenStack. So this is we can add the additional new feature into the Lustre Cinder driver later. So today, we support the Lustre striping, but it's not flexible. So hopefully, we can support more flexible striping support in the Cinder driver. So we are really interested in the PLF, the Pervasive on the file layout, because so once when we generating the image, as a first, the image itself is small, but when we writing the file inside of the VM, then the file itself is growing. Then the Lustre is automatically striping. So that kind of the stuff is really interesting. The snapshot support. So today the Lustre. So GFS supports a snapshot, but LSKFS support doesn't support snapshot. However, so we can support the snapshot in the Cinder driver because the KVM, the QM, the image itself, the support snapshot. So we can use that snapshot capability for the Cinder driver. So even the Lustre doesn't support the snapshot, so we can use the snapshot. We can implement the snapshot capability on the Cinder driver for Lustre. This is the same idea with the cloning. So we can support the cloning, the support as well. Then the job start related integration is really interesting with the Cinder driver as well. So again, the Lustre has a bunch of the interesting feature already. So we are very interested in the security feature integration for the VM environment with OpenStack. So for example, the subdirectory mount, so we can export the subdirectory on the limited the client. Then OpenStack so install the limited the directory, then not exposed to other people. Then also we support the Kerberos, so we can the more secured the VM, the host environment with a Lustre Kerberos capability with node map. Then also we can isolate the resource management for each of the directory on each of the job on each of the client. So for example, the project quota, so we can manage on the directory level accounting. So we can manage each of the VM, the size by project quota. We probably we can support the QoS feature on each VM because we know the client UID and the job ID, so we can assign to the job ID to the KVM process. Then so we can provide the control on the VM the I/O performance by the network request scheduler and the TBF. So that again the performance management stuff. So the PLF is really interesting for us for the VM image allocation. The QoS is also one of the important feature for the Cinder driver. Then we probably can manage. We can set up on the Lustre job stats, the monitoring for each of the VM. So you can see each of the VM, the I/O pattern, I/O throughput, the metadata operation on the graph. The conclusion, so we developed the Lustre Cinder driver. So now we connected the OpenStack and the Lustre. Then we just demonstrate the minimum requirement, the functionality. Then so it's working well today. Then we already contributing all the patch, the OpenStack, the community. So still the patch itself is going under the review, but hopefully the merging the upstream the OpenStack soon. After that, so we extend the more function to the Cinder driver, then integrating the other Lustre features as well. Then the more testing. Okay, thank you very much.
Are there any questions, comments?
I had a question about the Cinder driver. So does the driver run on each host? So then there's a Lustre client running on each of the hosts for the VMs?
Yeah,
okay.
Exactly.
Yeah, but not on each virtual machine, just on one, just on the host? Or is a client running within the virtual machine?
So the Cinder driver is running each of the host, the one with the Lustre client. Then so VM is running on top of that. Yep.
Anyone else?
This is just an off-topic question. Did you evaluate if Manila driver exists for Lustre? Or I'm not sure. Manila driver?
So that is one of the so my understanding is that is one of the distribution on the OpenStack.
That's the file driver, meaning like Cinder is for block, Manila is for file.
Oh, okay. Yeah. So we don't know, but so the community, the OpenStack community that suggested to us, so we need to push all the patch the dev stack the first. That is upstream the OpenStack the master branch. But maybe it's possible. I don't know. Thank you.